In the resilient modulus test, we will show how to determine the resilient modulus of given aggregate materials following the AASHTO T30799 testing method. The apparatus of this test is a resilient modulus loading device used for this study. It is a closed-loop, servo-controlled electrohydraulic MTS testing machine. It contains a function generator that is capable of applying repeated cycles of a Haversine load pulse. It is also capable of following a history supplied by the microcomputer control software. Before we begin the resilient modulus test, we must first prepare the test specimens. The specimens used for resilient modulus tests are fabricated using a split mold with an inside diameter of 152 mm, or 6 inches, and vibratory impact hammer without needing action. The height of the test specimens is 305 mm, or 12 inches. According to AASHTO T30799, particles larger than 37.5 mm, i.e. 1/4 of the specimen diameter, were removed from the aggregate samples prior to compaction. In the preparation of the samples, we first take approximately 12 kg of air-dried aggregates, add the required amount of fines provided, and mix the two materials thoroughly. We then add water into the material blend according to the target moisture content and thoroughly mix it in. Next, mount the membrane to the bottom of the triaxial base as shown here. We use a broken membrane here to protect a second unbroken membrane from being damaged by the aggregates. Carefully assemble the split mold around the membrane and clamp it together. Fold the membrane over the top lip of the split mold. Apply a vacuum to the mold to pull the membrane tightly against the mold wall by attaching the vacuum line to the hose coming out of the split mold. Next, we add and compact the sample aggregate according to guidelines from AASHTO T30799. In this case, it is placed in the mold in 5 even layers, and each layer is compacted using the vibratory compactor. With the compaction completed, we place the top loading plate on the compacted specimen and fold the membrane over the plate to form a seal. Apply a vacuum to the specimen through the bottom of the triaxial chamber base. This will hold the sample together when you remove the split mold. Remove the clamps holding the mold together and gently remove the mold. Add the second membrane to the specimen. Here we apply a light coating of talcum powder and use this metal spreader ring to assist us in sliding the second membrane over the first. With the second undamaged membrane now in place, we install a rubber O-ring at the top and bottom of the sample to ensure no air leaks occur during testing. Now that the test specimen is ready, we must prepare the MTS testing machine for use. First, we install the triaxial chamber and top lid. Ensure the rubber gaskets on the top and bottom are free from any debris which might otherwise compromise the seal. Tighten the nuts in a star pattern to ensure the lid is clamped on evenly. Next, place the triaxial chamber right below the loading shaft, or actuator, of the MTS loading frame. Move the triaxial chamber around to make sure the specimen is in line with the loading shaft. Depending on when you conduct this lab, you may need to turn the testing system on and prepare it for testing. Press the console power switch to turn the system on. Turn on the computer located beside the control unit cabinet and log in. Open the LabVIEW NXG program located on the desktop. While that opens, press the low then high buttons on the MTS 436 control unit to turn the hydraulic system on for use. Before doing anything else, open the program named SetupRM in LabVIEW and run it. This program monitors the load, displacement, and cell pressure transducers and displays their values on the screen. This allows you to monitor the load and cell pressure while you set up the sample before and during testing. Finally, adjust the control knob called Set Point on the 406 controller clockwise very slowly to bring the piston of the actuator down until it touches the loading shaft of the triaxial chamber. This particular controller is the one located directly to the right of the 436 control unit. This process should be monitored through reading the load cell on the computer. The applied load should be between 40 and 60 newtons. At this point, we are finally ready to conduct the resilient modulus test. First, connect the air pressure line to the triaxial chamber and apply a confining pressure of 15 psi. Measure the pressure reading from the computer. Release the vacuum in the specimen and leave the valve open to maintain a drainage condition. In LabVIEW, open the conditioning control program called Grand Condition. Before running this program, make sure to stop running setup.rm first, or the program will throw an error. Click Run to condition the sample. The control program will then run a conditioning cycle to prepare the sample for testing. Once the conditioning cycle is completed, run setup.rm again and adjust the cell pressure to 3 psi. Open the program called rm log 15 seconds and click on the 3 psi tab at the top of the program workspace. Stop running the setup program and run this program. The computer will then run the resilient modulus test routine for a confining pressure of 3 psi. Once it is finished, you will want to collect the data from the test. To do this, click the Import button at the top of the left window. Look for the raw data file in the folder called LabVIEW Data. It is most likely the most recent data file present if sorted by date. Import this file into the program. Click on the imported file and then click the Export button located beside the Import button. A window will appear. Here, you can export the data file as a comma-separated values, or CSV file, rename it, and export it to a convenient location for collection, such as a folder on the desktop. Adjust the cell pressure to 5 psi and repeat the previous 2 steps. Change the control program to the new confining pressure, then run it and export the data. Repeat this again for a confining pressure of 10, 15, and 20 psi. Once the test is done, very slowly adjust the knob on the 406 controller in the anti-clockwise direction to bring the piston up. Release the cell pressure, remove the triaxial cell from the loading frame, and disassemble your sample. Don't forget to extract your data from the computer before leaving the lab. You will need to store it on a portable drive, such as a flash drive, as the lab computer has no internet connection.